Okay, having a look at this cold room. Apparently they've turned it on start of the season and it's gone bang. We don't know how it's gone bang because nobody's about. Let's come on. Oh, it's gone bang. Well, I think I've heard a rumble. I wonder if it's on pump down. I wonder if it's on pump down. If it's on pump down, that would account for the rumbling. It sounded like it was coming from it. Could be there. We've not done us a lot of favours with that sheet of tin. Really, I don't quite know how we're going to get to that. We might not need to. Okay, there wasn't really an earthing point, so I've wired an extra earth wire in just for our test lead. And then we have been checking these, and that was reading 1.4, something 1.5, 1.65, and then the next one up was the same-ish. So what I suspect it is, you're going to have, say, as a guess, defrost heater, you might have fan motor, you might have solenoid valve, you might have the compressor or something, you know, and another thing on there as well, one of the things. All the neutrals are probably joined together. Well, there's some neutrals there. They will come to this block here, so we've got 1, 2, 3 neutrals in there, 4, and then 5, so we've got 5 neutrals. So we need to separate all those. Otherwise, if this one was faulty up here and we test this one, it'll go all the way into the thing, back out, and then up the neutral wire, up down the neutral wire to the faulty thing, and up to there where we, which will make it look like that's why they're all reading the same, basically. It's not very earthy, so it might be a live and neutral fault. If you get a dead short between live and neutral, it pulls so much current it will take the breaker out and the earth leakage trip. Although saying that, I'm talking at my arse because this didn't take the breaker out. It just took the RCD out. So we are looking for an earth fault. Yeah, let's get all these neutrals split. Okay, we've just split the first two. So I'm on the neutral of whatever that one is, and this one 43. That's fine. And then we're going to go on the next one. 3.2. So that could be the faulty one, because if you've got two parallel paths to ground, you've got the 43 mega ohm ones which we've just got, and then the 3 mega ohm one which we've just got there, plus all the other stuff. So it isn't going to read 1.6. I would assume. Yeah, see, we've got 3.5 on that one as well. So I think we'll split the rest of them and see, because we've got one other neutral there and a link wire. So we'll take these two out of here, and then we can test that one. And then we've just got that big neutral there and that one there. I don't think it's the unit. I suspect the compressor's on pump down. I think that was the thing that first fired up when we turned this on. So I think the problem is either going to be on this black wire here or this one here. Okay, got those split. And let's see, what have we got here? 181 mega ohms, that is fine. So let's go on there. 3.6. I mean, it could be, I have had them with motors where they test okay, and then as soon as you go to put power to them is when they when the fault actually happens. Let's see that go there. We're taking out the right side, I think. And then, so that blue wire is, we think, And then there's that one. Let's get this. Okay, let's try the blue one, which we're guessing. We think that is the compressor, which we think is okay. 3.6 mega ohms. Maybe it isn't. And then I think that one was the other one. 3.7. This is going to be fun. This might turn into one of them where you have to power them up off individually and see which one makes it trip. Let's think about this. What would have come on when it come on cooling is we think the compressor comes straight away because it's on pump down. So unless that took a little while for the trip to come in, but it seemed to be like when this board decided to turn on the cooling that the thing tripped. So we think the compressor's okay, but we can wire that back in and see if it pumps down. So what will come on when it comes cooling, unless it's defaulted to do a defrost as soon as you power it on, which you can do on these things, but it's very rare that anyone, I never set them up to do it. So the most likely thing it's going to be is the fan motor or a solenoid valve if they've got one that's gone faulty. Unless it could be a wiring fault, you know, could have mice in there or something, made a little nest, chewed through some wires. Right. The view screen's gone rubbish on the camera, so I can't actually see always what I'm pointing it at. Let's turn this on. Well, it's either took the power out again or something isn't running. Let's turn it off again. Okay, we've got no power coming in. We've tripped the whole building out. There's no power in the whole building, so I've traced the cables back to about 2 buildings further away, which is where all the mains incoming power is. So I suspect we've got a main earth leakage trip in there, and we've knocked that out. But because it's their workshop, it's all locked up. So we've hopefully got somebody on their way to come and unlock it so we can get in there. But in the meantime, we'll carry on, I think, checking these out. But I mean, they're all reading around, well, we've got about 3 mega ohms on the unit and about 3 on this board, neither of which are, on paper, would be bad enough to make the trip go. But it might be, if it's a motor, it might be a bit earthy when it's not running, but get really earthy when it goes to start. So we might have an issue that it tests sort of tolerable, but it fails when it goes to start, which is why we were splitting it into 2 halves to see. Anyway, waiting on somebody with some keys now. Okay, we've got a load of the neutrals tied together and away you go. And then if we test them all together, 36, 37, and the difference that's made, it was reading over 100 until I put the third one in. And like I say, each one of these is a parallel path to ground to earth. So if you've got, the more parallel paths you've got, the easier it is. So the lower the resistance will be. And then this one, the last one here, reads 3.5 or something, 3.3. Don't know where that one goes. And just put it on there for now, and then we can get in there. And this is what we think is the condensing unit, and that's reading 4.2. I don't think it's a condensing unit. It could be, because when we first turned the power on, it started up and I heard something run, which I thought might have been this fan, but I don't think it was in retrospect. I think this did like a 30-second, well probably not even that, 5-second think about it before it powered up any of the outputs, and as soon as that powered up the outputs, the trip went. So wherever that wire goes there, which is the top one, which I don't know, aux relay that is, aux relay 2, nothing in aux relay run, 1, fan test okay I think, defrost, and then we've got power supply, and that might be the compressor run signal, I don't know. Yeah, so we can test the fan, which is there, 36 mega ohms, which it will because all the neutrals are tied together, and that's the defrost heater, 37, which is good, and then this one we don't know what it is, 37, that might be a solenoid if it's on pump down. Don't know if it says under compressor R1, yeah, compressor, so that's going to be a solenoid I think if it's on pump down, so solenoid test's okay. So it's whatever we've got on that auxiliary thing there, which I wonder if it's a fucking light fitting. Could be a light if they've got, could be a light fitting if it's not that, because some of these you can, oh dear, plastic's broken in there, look at that, let's go around here. Yeah, some of these you can, you've got a light switch. Some of them you can turn the lights on and off from this. I don't know which relay that is. It's probably programmable. Yep. Okay, we've just took the solenoid off, and then if we test the compressor wire, we get 500 and thingy bob ohms, so the cable's good and the coil's good, so we still don't know what that wire does. I think somebody's turned up, maybe they've got a key. Okay, we've got all the neutrals in there, that's the board. Next one up is the solenoid, which is because I'm pumped down, and the next one up is the fans and the defrost heaters, so that one's doing the job of 2, which accounts for that 1, 2, 3, 4, and then we've took this one out of normally open auxiliary relay 2, and then the other end of that is in that bar, that thing there, so it's completely disconnected. So let's turn it on. No, I was right, because it pumped down, didn't it? We pumped it down. So that's why. So that's come on. That's running. That's running. So what I'm going to do is I'll get my tester, and I'm going to go on the output of auxiliary relay 2, and I'm going to press the light bulb switch in the front and see if that goes on and off, live on and off. If it does go on and off, then we've proved that is the feed to the lights and the problems in the light fittings, or the cable to them. Yeah, the problem is the lights. When you press the light button, and then the relay click, you can actually see it switching. That is the light feed, so basically when they turned it on after it's done its little 5-second think, it's come on, powered up the fan, the solenoid and the lights, and that's the lights that's took it out. So we might pop the cover off and have a look in there. If it's just one of them, we might be able to get them some illumination. It might be full of water. They've had a lot of rain or something and water's got in the top. People don't seal them up very well, they just run holes in them. I mean, what you should do is come out the end with a bit of flex, so and then join it outside. I'd never run conduit into a light fitting in a cold room because it causes condensation into it. Anyway, looks like it'll be cooling again for Monday. I think the shooting season starts. Okay, that light's checked out. Okay, the first one, and the second one we've got 0.12 mega ohms off of the connector here, and you can see all the condensation. full of water. Like I say, it gets into the holes. They should have gone out there with a bit of flex. Put a stuffing gland in there or something. And even when you put screws in like this, you've got to be careful. They want a bit of silicone around them or something. Or a bit of rubber gasket, you know, like a rubber washer underneath. It'd be cold in here when the ring's running, and if it's warm and humid outside, all the moisture's just going to go where it's cold, like condensation on a beer glass, and it'll just fill the fittings up with water. I've seen them in freezers where they've literally filled the what do you call it, lens, whatever, completely filled out with water, and the whole life it's a solid block of ice, where people haven't sealed these up. You try and explain it to Sparkies, they don't always listen. At least these are the right way for the airflow, because otherwise they like to put them crossways and it buggers the airflow up. But anyway, I'll leave this disconnected. I'll connect that one back in so they'll have some light in here, but ideally I'd put 2 new LED light fittings in here, I think, if it was me. Okay, take that up. Ready to go back in, whatever they decide to do with it. Okay, if I'm right, I should be able to turn this back on. Compressor's on, pump down. Thinks about it, turns all the outputs on. And the light works. There we go. It's almost like we know something. So that's me, Milwaukee light. I was saying it's quite good, but that's burnt through a 2 ampere battery, and it was on for a bit last night as well, so I don't know, an hour or so. So if you're going to run one of these, you need a bigger battery. We'll run it on low power. It's got 2 power settings, I think. On the high power setting, it's probably lasts a lot longer than the lower one. But anyway, it's a handy thing to have, especially if you're getting older and you can't see anything anymore. Just have a look at the system. State that coil. Oh, it's a good brush. It's all full of dust and feathers off the birds. It's quite an old system, so. Back out here with some new light fittings, just to prove the point. I was taking the cover off this one, I thought, oh, it's got a bit of a tide mark in it. And all too late I realised it wasn't a tide mark, it was actually full of water. You can actually see that one. It's got water in it as well. So I took a shower off under this one. Yeah, so you can see the water on it there. So that must be getting in through the top where they haven't sealed it. Okay, got the new lights wired in. Back to extend the cable. I've siliconed all around when they come from the roof. Stuff them in there and filled it full of silicone. I've done similar to that one. And I've used them clips. So the only opening into the light is where the cable goes in. That's got a gasket stuffing gland. I don't think anything can get in that one. This one we've got 2 cables into one hole, which is never good, but she's got a gap. But we have pushed half a tube of silicone in there, so hopefully that'll last a bit better than the old ones did. Okay, job done. That's a handy light, Milwaukee. I don't know what the model number is. You can angle that about. It's got two power settings, and it folds down. You can set it at that height. I think it rotates, so yeah, you could actually set it down that level if you wanted. That folds, locks in there. Buttons on the side, it just folds up. I've got it on this, I've got a cheap, got some proper batteries, but I just got this cheap Chinese one. It's 8 amp hour. It does run for quite a while. If you put it on the low power setting, it does run for quite a while. That's my towel. Drying my bloody head. Getting absolutely soaked. But that to put over it. Right, anyway, ready for shooting season.